last presentation. So I think it have leave 30 minutes. Professor Yun?
Yes.
Yes, come from Korea. Welcome.
I'm very glad to see you in front of you today. My name is Mr. Yun. I'm not a professor. I'm just the officer manager in the PSM, Pyeongsan Metal in Korea. I'm representative of some logistic management in my company. So today I'll tell you about the study of the international transportation route for the wind power equipment manufacturing company. Today's my topic consists of three parts. First, notice the status of the wind power equipment logistics nowadays. And then second, I define the logistic route and with subdivision. So I'll start right now. I will tell you about my topics following this flow chart, from introduction to finally the conclusion and suggestion. Maybe you can see you're also interested in the renewable energy today. The environmental pollution and the exhaustion of fossil energy and then Japan's nuclear power disaster. These items make interest in renewable energy today, all the countries. Solar cell, wind power, water power, and so on. Among them, the wind power energies, the operating cost is the cheapest all of them. About $58 per kilowatt per hour. So this is the trend of the worldwide wind power energy. Each government. As for EU, by 2030, a total of 300 gigawatt wind power development plan is spread all over the country. As for China, up to approximately 270 gigawatts by 2030, by installing a domestic wind power requirements to 8.6% will be replaced by. And about Korea, Ministry of the Knowledge Economy announced the roadmap for development of offshore wind on December 2010 years. Look at this graph. That's the stages of demand for wind power equipment and base. As the global cumulative installed capacity from 1996 to 2008. That's increasing. But I found that wind power equipment is just a big and heavy covers. All the people and the nations just define just the big and heavy cover. So there's no research about the transportation route. So I studied about these topics following this flow chart. At first time, the logistical characteristics of the wind power equipment. I define the third step. All covers or transportation consists of three steps. The first, second, and third step. First step means the domestic transportation in the supplier's country. And second step divides from port of discharge to the POA, port of arriving the country. And then the third step is also domestic transportation in the final destination. I will tell you the step by step. Look at these photos. This is the wind power equipment, the porters. This is the head part of the wind tower, the top side of that. And then this is the body, so long the pipes, big and long pipes like that. But it's not pipe. All the part is consists of like these flanges, part, and then make long. And this is also another accessories for the wind power equipment. Bearings in the main shaft and the flanges. Also, each covers more than 2 tons per each. And then as for flanges, its width is more than 5 meters. So widely covered. So this is my topics. The summary of transportation, the solutions to problems of international logistic routes for wind power equipment. Step 1, as for the domestic routes, problem, durability of institutions on oversized vehicle permit. And then different locational conditions among companies within the same business. Second step, increase logistic conditions for D3. D3 means the D-type importance. Limited logistic routes. Limitation in inland transportation means according to product characteristics. And then finally, differences in conditions of inland transportation. You will see the step by step each topics. I suggest you the problem and status and solution from now. Okay. The first and third step is have a same problem, because from supplier's country and final destination have the same problem like this. It's the difference of each country's weight limit standard. There are different rules, different standards. As for Korea, the action load maximum limit done is 10 tons, and the total weight can 40 tons. And then dimension also like that. Width is just 2.5 meters. It's a standard. But as for USA, if I use the multi-axle, the axle load is 14.5 tons for one axle. And then the simple axle load is 9.1 tons. Total weight is less than Korea. As for France, in France the multi-axle can accept 19 tons, but just a simple axle load just 13.1 tons. And then the width dimension is similar by each country. My point is, if we make some standard, all over the country make the same standard. As for the manufacturing company, it's very confusion and then very difficult for them. If I export to Japan, if I export to USA, export to France, different standard, different transportation route, different rules. Second step, overseas transportation. There are many other countries, there are many different ports, many different countries. There are many routes, but there is no subdivision along transportation route. Supplier just send the cover, just delivered by the ship. There are many lines, shipping lines. Transit time is different. Inland transportation different. Even if just from Busan to Spain, some shipping lines takes 38 days, and then another shipping company suggests us 45 days. Very different. So it's problem also. So I subdivision of the transportation route. I subdivided, defined three kinds of transportation routes for the overseas transportation. The first, I called the access priority route. This route means that both final destination and the nearest discharging port, we call it the POA, is located in same places. So from discharging port to final destination takes not more 1 day. Look at this. If I export from Busan to Savannah, USA, we will send the sailing route from Busan to Houston, and then after discharging in Houston port, and then use the inland transportation by trucking from Houston to Savannah. It's the direction, the ways, it takes 1,643 kilometers. It's the nearest port. Second, economics priority route. Maybe many of manufacturing companies follow this route. It's the lowest cost route for the supplier. Never mind transit time, never mind transportation method, never mind schedules. Only cost down. If I send to some Windsor from Busan, go to with the ocean sailing from Busan to Vancouver, and then from Vancouver to Windsor, take the inland transportation by trucking. As the direction is 4,071 kilometers. Takes a long time, but takes a so low cost. The manufacturer can save the money about this. And then finally, convenience priority route. This route is the best way I suggest that. The easiest way to transportation. It's similar with the access priority route, but as for the access priority route, have some little longer inland transportation time. The convenience priority route, as for the cost, this route is the most expensive, but very safety and the stable of the delivery time. From Busan to Dijon in Spain, was sent to the Busan to Bilbao by the ocean sailing. From Bilbao to Dijon takes just only 40 kilometers by the inland trucking. So I suggest the divide, not only just the transit time. We must subdivide the access priority, convenience priority, and the economic priority. We must subdivide about all the routes. And then second, the limited transportation method for route. I told you at the postcard, the wind power equipment is heavy and so wide cargo. So if I want to send the cargoes from Busan to Europe, if I can use the railway from Busan to Europe, can use the TSR if it allows, but the wind power cargoes cannot use a rail car by this, and it's heavy weight. Cannot use a non-regular bulk vessel because of increased rate for the short-term order by JIT system. It means the just-in-time by Toyota. Look at this picture. On the May of this year, in Canada, can use the rail car for the transportation of the wind power equipment. You can see that these flanges can reverse. Try to transport the wind power flanges by railway from Vancouver, Canada to reverse transportation. Some flanges among them has some damage on the surface because of the weight pressure. So we're going to get detailed quality inspection in the final destination. If it will pass, we can use the railway from Busan to Europe like directly. Use the TSR or TKR. The solution, I suggest you the last solution for the destination inland transportation. We must establish an operation of the World Logistics Organization, I called it. We need establishment of international integrated road law and driving restriction rules. And then integrated definition on size of cargo vehicles among the nations. The professional research on the international logistics routes and the organization and provide information on import and export logistics from a neutral point of view, though exchange and sharing with trade associations of differences. Need to establish and operate an organization for comprehensive logistics assistance and integration. I mean, we must make the same rules, the same standards for all over the world, for the road condition. How can we use this study? I calculated the expected monetary value on this study. Totally about more than $110,000 million, just only for in Korea, not all over the world. This data is based on domestic production on 2011 export industry. The wind power, shipbuilding, plants, all this business takes a big and widely cargo as a wind power. The rest chapter in my presentation today, conclusion and suggestion. Research conclusion. Future change in size of transportation for wind power equipment. Transportation fuel is expected to continuously grow with increasing wind power generation. And then we must define not just the simple heavy cargo concept. I suggest to you the wind power equipments are the specialized cargo, not just big, not just heavy. It has the logistical characteristics. Solution to restriction in domestic transportation. I think we must unificate all of the countries, the standard and rules, the road limits, and so on. Make the WLO, World Logistics Organization. Like that. And then we must divide just overseas transportation routes, access, economic, convenience, priority. We need all of that. And then we must use that subdivision for the cost and use the export cargoes. In this study, I have some limitations after finish this study. First, the selection of a research topic was linked to just wind power equipment, not just all oversized cargo. And second, conducted in accordance to deliver deadline of manufacturers. Study was just focused on theoretical definitions and current stages. Only concentrated on logistic routes without concentration on expenses. Only the concept of World Logistics Organization was just proposed. It's our homework. So I suggest for the future research, the utility of container vessel and bulk vessel in handling large size steel products. Economic feasibility of international logistic routes. And railroad transportation method and applicable routes for wind power equipment. And the details on establishment and operation of WLO. This is, I suggest, for the future research all over the transportation research organizations. And then this is appendix pictures. Case of rail transportation for wind power equipment. Maybe you can see the first cut. Look at this. Just round-shaped flanges, but it changes some kind of weight pressure on it itself, so like pressure. So it changes shape. So it will be the detailed inspection in the final destination. And then if they see that this is okay, you will use the railways continuously next time. And then this is the case of inland transportation for wind power equipment in Denmark. In Denmark, we used to make some reverse on the trailers and go on the road. This is the Denmark Aarhus to Brande. We call it reverse transportation, just to make the shape, a different shape. Okay, that's my presentation. Thank you for your listening, and then if you have any questions, please ask me. Do you have any questions?
Okay. Any questions?
Not interest?
Thank you very much for your very interesting presentation. I have a kind of question about you mentioned in conclusion about wind
power equipment.
Yeah,
yes.
Your equipment is not just not simple heavy cargo.
Yes.
It's a special.
Yes.
So that what is different with conventional heavy cargo, or I mean I know that some Japanese company like Hitachi
Yes.
electricity company, they also exported some power generators,
Yes.
not wind, not
Yes.
some generator for the thermal power plant or something. That is also heavy goods, and they transported from their factory to port by the specialized trucks.
Yes.
And so what is the difference, the conventional such kind of cargo?
Okay, sir. Before I start this study, many people asked me like that question. What's different any of the conventional heavy cargoes and the wind power equipment? I think conventional heavy cargo use the bulk vessel mainly, but wind power equipment use the containers nowadays. Open top containers and pre-packed containers. That's the different way. Because if I use the bulk vessel, it's not the regular vessel, so you cannot take the deadline for the delivery to the final destination. But the containers has a weekly schedule, so we can use the container, and then we can have a promise with our customer. So that's the main differences with the conventional big cargoes.
Okay.
Yes. Any other questions, sir?
Okay. Let's thank you again. At the end of this presentation, I'd like to give a new notice of our campus tour. The place that I will visit is changed to Maritime Museum, and please pick up our packages and meet in front of the door of this building, and to ride the bus. The time before